everyone, welcome to my channel and welcome to part 2 of the mini-series 10 SQL tricks every data scientist should know. So in my previous video, we went through the first 4 basic SQL tricks. If you haven't watched, it will be linked down below, so feel free to check it out after this one. For today's video, we will continue our journey and get onto the additional 6 SQL tips and tricks. So without further ado, let's get going. Today we'll be working with this toy data, and same as part 1, this exercise will be implemented in Microsoft SQL Server, but if you work with different platforms like MySQL or Oracle, the logic is exactly the same. So this data set will be linked down below along with a short guide on how to load it in Microsoft SQL Server so that you don't have to type in everything. And now if you would like to follow along with this video, do make sure to check those documents out because that will save you some time. Alright, now let's take a look at the toy data first. So this data is a made-up data in a longitudinal format, which contains records of customers logging into our website and the amount of money they spent. So we have the ID variable coded as string that indicates the individual customer ID. And then we have the numeric variable coded as float numbers. And that's the dollar value of how much they spent during this visit. And then the next one is the gender variable coded as string, very straightforward, the gender of this customer. And then lastly, we have the date variable, which coded as date. And this shows when this transaction happened. So as we can see, each customer could have multiple transactions with a corresponding timestamp. So this is a typical longitudinal data set that you would work with as a data scientist. And now our first task is to find out the difference in money spent comparing 2 consecutive logins for each customer. So for example, customer 0155, she logged in on 601 and 602. So if we look at the numeric value, we can see that both of them are 60.79. So the difference between these 2 consecutive logins is 0. And then how do we go about this in SQL for all the ID variables and all the record within each ID variable, right? So this can be easily done with the function lag and the lead, which probably are my 2 favorite functionalities in SQL. So basically the logic is we're going to get the previous value for each individual row and then use the current value minus the previous value, and that will give us the difference between these 2 values. So let's see how we can do it in SQL. So we use the lag function, which takes in our numeric variable, and we're looking at 1 row prior to the current row. And if there's no prior row, which basically means the first row for each ID, then we will use the default value 0. And then over partition by the ID variable, we also order by date. For this derived value, we will call it previous number. Run this chunk of code. Now we can see the previous number column stores all the values for prior value to this current row, right? So next step, all we need to do is to calculate the difference. Data numeric variable minus our data previous row. And for this one, we will call it number diff. So running this returns this table. Now we can see the number difference variable calculate the difference between the current row and the previous row. So for example, this negative 46.44. So that's the difference between 14.35 and 60.79. We're doing the same calculation for all the records and all the customers as well. Trick number 6, handle the infamous top-end problems. When it comes to the top-end problems, it's likely that you will come across at least one of them in your interviews with high-tech companies. So today we will tackle this task where we need to select the top 3 records with the most money spent for each customer ID. Now, again, here our target is each individual customer, so we will use the partition statement. Use the function row number to do this by each individual customer ID, and we will also order by this numeric variable sorted decreasingly. We give this variable a name row number variable. Run this chunk. For each individual ID, we created a unique incremental integer value to each row. Next, all we need to do is to select the top three. Row number variable is smaller or equal to 3. We also order by this variable. Here we have the top 3 records for each individual customer based on the numeric value, which is the money spent on this visit. So one thing to point out is that this customer ID 0180 was correctly returned as just one record, just as other IDs with more than 3 rows. So basically the row number function in SQL is quite forgiving as to whether or not the raw data has enough rows for the number n specified. This function is a very, very convenient and straightforward function to use. Trick number 7, using with statement to keep it dry. So as we can see, this query contains a subquery. So in order to increase its readability, we can reorganize it using the with CTE. Here, the CTE stands for common table expression. So that is a temporarily named result table that we can use the back and forth. Copy and paste, call it with row number table. As if we want to select, we can just call this table name with number table and where row number value is smaller or equal to 3, and all the rest are the same. This will give us exactly the same result as before. But the benefit of using with clause to create a CTE is when this table is referenced multiple times and without repeatedly writing the same subquery again and again, we can just introduce the CTE upfront and reuse it later. And that is the dry principle, also called don't repeat yourself principle. Trick number 8, concatenating to reformat your data structure. Now our next task is to create an aggregated report for our internal stakeholders. And in this report, it will show the dates each customer logged in. This task will be an aggregation of many-to-many information because for each individual customer, he or she has multiple records. Also observed that the ID variable and the gender variable both contain duplicated values across different rows. So therefore, in order to make it suitable for human reading, we immediately think of the string aggregation function in Microsoft SQL Server. Aggregate over this date variable, use comma to separate different values within group and order by this date variable. And now we call it the concatenate date variable. Here, because we're using the string aggregate, which basically is an analytic function, then we need to group by and our gender variable. Now let's run this code. As we can see, the concatenate dates variable combined all the different dates for individual ID, and this creates a much more readable report for our internal stakeholders. Trick number 9, regular expression in SQL. To me, I don't use regular expression in SQL all the time, but sometimes this can be very convenient for text extraction. Looking at toy data, you may have already noticed that there are typos in our gender variable on row 2 and also on row 8. So now our task is to select all possible female records regardless of typos. So this is a perfect example for us to use regular expression to match the strings. Like start with the letter E, and then there's any letter in between, and end with the letter E as well. So running this code, it selected all the female records, including the 2 typo rows. What this regular expression does is specify the letter E as the starting and ending point of this pattern. And in between, we use this A to Z to match any character from lowercase a to z, and then we add a percentage sign to indicate anything after that. This is one example of string matching, and regular expression is a very powerful tool to work with unstructured text data. So if you are interested, I will leave some useful resources linked in the description section. Trick number 10, integrating SQL with Python. The prerequisite of integrating SQL queries into Python is to establish the database connections via ODBC or JDBC. So for this video, we will skip it for the time being. We will assume that we already have Python connected to our database. However, if you are unfamiliar with how to set up the Python API to SQL, please feel free to leave a comment down below. I will create a video dedicated to this. And then in order to call the query, what we can do is just write the query as a string and then pass it to the pandas read SQL function. We can see the return here, which matches our data table exactly. Now, this is the most basic example where we have a standalone and fixed query. However, we can also create dynamic queries from Python to SQL. So leave a comment down below if you are interested in learning how to do that. And also, if you'd like to learn the equivalent version in R, leave a comment as well.
Now with this, it concludes our SQL mini-series where we discussed the 10 SQL tricks to level up your analytics. If you have any questions, feel free to leave them in the comment section. All dataset, code, and the materials used in these videos will be linked in the description section down below. Thank you so much for watching, and don't forget to subscribe to my channel for more data science, analytics, and programming videos. Bye, folks!